Alright, so the next thing we will be talking about are irrational numbers. Alright. Okay, now based on the previous definition of rational numbers are numbers that can be written as a fraction. So what do you think is irrational numbers? So it means the opposite, correct or not? Right? So which means irrational numbers are numbers that cannot be written as a fraction. Okay? Right? Irrational numbers, alright, they are numbers that cannot be written as fraction. Okay, let me highlight this one. It cannot be. Alright. Okay, can you see the pattern over here? So, try to think. If we can't use a fraction to describe an irrational number, right? Which means we can't use all these ways to describe an irrational number, right? So how do we describe our irrational number, all right? Now, what is irrational number in the first place? Now, to show this example, I'm gonna be using a square, all right? Power, all right? To show you an example. Now, let me give you a simple example here. Now, take a look at here. I have a whole number, 1, 2, 3, and 4, all right? Now, these are our whole numbers. If we take our whole numbers and square it, all right? Square it means we will be power by 2, all right? Square it. So what do we get over here, right? What do we get? Right, 1 square, we will get 1. 2 square, 4. 3 square, we will get 9. And 4 square, we will get 16, right? Okay? Now, very similarly, we can do the reverse, okay? Now, what do I mean by that? Now, take a look at this whole number. This is the original number that I have used, correct or not? So, which means I can also write like this. If I were to take the square root of 1, the answer, all right, I will get 1. Okay? If I were to take the square root of 4, I will get 2, right? Okay, if I square root this number, I will get back the original number, right? So same thing over here. If I take the square root of 9, I will get 3. I will get back the original number, right? Same thing. If I take the square root of 16, all right, I will get 4. All right. Now, what I want you to focus is these numbers over here. Now, take a look at these numbers, and I will plot these numbers into a number line. Okay. Now, let's take a look here. All right. Square root 1. All right. Number line. Okay. So square root 1 will be the most left. So let me write here. I have square root of 1. My next one, it's square root of 4. So, okay, let's just say it's around here. Square root of 9. Okay, should be around here. And square root of 16 will be further away. But for this example, I will stick with this only, okay? Now, try to take a look at this number line, all right? If I have square root 1 over here, 4 over here, which means square root 2 and square root 3 exists, right? Same thing over here, square root 4 to square root 9. What do you think is the missing number in between? It will be square root of 5, square root of 6, square root of 7, and square root of 8. right? Now take a look at this. This number over here, we have simplified this number, right? Square root of 1 is what? It's 1, right? Square root of 4, it's 2, right? Square root of square root of 9, it's 3. So these are my whole numbers, and we can see from here whole numbers are part of rational numbers. But what do we call this number over here? Right? What do we call these numbers over here? So these are what we call an irrational numbers. Okay? Numbers that cannot be expressed or written as fraction. Okay? Now there's a special name for all these numbers. We call them assert. Alright? We call them assert. Okay? So surds are irrational numbers. Okay? These are numbers that cannot be written as fraction. So back to the question on top here. So in what way we can use to express our irrational numbers is by using a square root. Okay? So we can show, alright, we can show irrational number alright, by writing square root of x, okay, or square root of x, and then over here can be any positive number. Okay, so this is how we show irrational number. But do take note, not all numbers written in this form are irrational. Take a look at this number line again. Okay, like for example, like look at this 4, square root of 4. Based on this definition, it should be an irrational number. But the thing is, we can simplify this, right? If we can simplify this, it turns to a whole number, and this belongs to rational number. If we can't simplify a square root, all right, or if we can't simplify this, a cube root for example, all right, n can be 3, again, an example can be, right, this n can be any positive number, for example 3, a cube root of any number, let's just say 5. Okay, we can't simplify this. So this is a cert, and certs belongs to an irrational number. Okay, so if any square root that can be solved of f, if any cube root that can be solved, it will be a rational number. Okay, now more examples over here. Let's say I have, let me write over here. Okay, let's say I have an example over here. Square root of 25. Okay, square root of 25, right? Based on this, it's a cert, but no. Square root of 25, we can simplify this and can get 5, right? Same thing, if I have cube root of 8, okay? We can simplify this, all right? You can use your calculator and check, and you should get 2. And all these they belongs to rational number, okay? So remember, irrational numbers are numbers that cannot be written as fraction. And how do we usually express irrational number is by this form or this form. Okay, but do take note that not all numbers written in this form are irrational. If they can be simplified, like these examples over here, okay, they are not irrational. If they can't be simplified, like all these red numbers over here, they are irrational numbers.